Hello guys, welcome back to my channel. So today we are going to talk about what is cyclic hardening and cyclic softening. What is the difference between these two concepts? So uh, let's talk about what is cyclic loading. Cyclic loading in the sense when a material is subjected to a repeated loading or unloading, whether it is a tension, compression, bending, torsion, any type of loadings, which is a repeated loading and unloading. The response in the sense the stress and strain response can change with the cycles. Okay, so that we call it as so what are the changes we observe? One is cyclic hardening and cyclic softening. These are the two changes we observe when there is a repeated type of loadings and unloadings. Let's discuss each terms in detail. So what is cyclic hardening? Cyclic hardening occurs when a material becomes stronger and stiffer with increasing load cycles. When the load cycle increases, so it becomes stronger and stiffer. So the stress required to produce the same strain increases with cycle. Okay, so if you see this hysteresis slopes, it actually expands vertically. You can see, right? This is one cycle, this is another cycle. It actually expands vertically, and the yield stress is also increases. If you say, take this is my yield stress and this is another yield stress. So as the cycles increases, as the hysteresis loops increases, my yield stress is also increases, and the plastic strain per cycle reduces. Okay, so that is the thing. So this actually the physical phenomena is there is a dislocation multiplication in the material, and there is a dislocation entanglement, and these are the reasons like increasing the resistance to slip. So these are the mechanism in the material happens. So because of that, the material get hardens. Okay, so these type of cyclic hardening behavior can be seen in these type of materials. One is low carbon steel, acidic stainless steel, and some aluminum alloys. We observe this type of phenomenon. So the practical example here is a steel component under cyclic bending. Okay, so the initially it yields easily, but after a few cycles it resists the plastic deformation more. This is a some of the practical example for the cyclic hardening. So what is cyclic softening? Cyclic softening occurs when a material becomes weaker with repeated cycles. Okay, the stress required to maintain the same strain which is decreased. You can see right after uh, you can see the hysteresis low. It actually shrinks vertically, and the yield stress is also decreases. The plastic strain per cycle is also increases. Okay, because of that, we can see the softening behavior in the material. So it becomes weaker with repeated cycles. So what is the physical phenomenon mechanism for this? Why it becomes weaker after some certain cycles? So it because of dislocation, rearrangement, recovery or annualizations of dislocation, microstructure degradation, damage accumulation. These are some of the mechanisms we observed in the materials. Because of that, this behavior can be observed. So what are the common materials? So if you see the nickel-based superalloys, tempered steels, materials at high temperatures, you can see the softening behavior at elevated temperatures. If you go beyond 600 and above, so we observe this type of cyclic softening. So the practical example here is the turbine blades material at high temperature. Usually the turbine blades undergoes with very high temperature. So initially those materials are strong after some few cycles. So it becomes softens with thermomechanical cycles. These are some of the practical example. When you see the comparison table between cyclic hardening and cyclic softening, so the stress levels actually in hardening it increases, softening it decreases. The hysteresis loops actually expands, whereas in softening it shrinks. And if you see the yield strength, uh, is increases in cyclic hardening and decreases in cyclic softening. Plastic strains reduces here, and in softening it increases. Typical conditions. This can be observed, this hardening behavior can be observed in the room temperature and softening can be observed in high temperature. The fatigue life often improves in hardening, whereas the softening we can see the fatigue life reduces. Okay, so these are some of the comparison table, comparison between the cyclic hardening and cyclic softening. If you are facing any interviews, if they ask any question, what is cyclic hardening and cyclic softening in fatigue? So this is the answers you can just easily grasp or see the loops, the hysteresis loops, how it is behaving in cyclic hardening and softening, and you can easily explain to them. Okay, so that's all for today. Okay, thank you so much. So we'll see you in the next video. Thank you.